Hello, today we will be reviewing educational Codeforces round number 92 that just ended 15 minutes ago. I think problem sets was rather interesting, if kind of on a harder side for educational rounds. So, the first problem, problem A. Here we have a segment from L to R, and we need to answer if there are two numbers within this segment so that the least common multiplier is also within the segment. And if there are such numbers, we also need to output two such numbers. Well, first thing we need to see is that if we have two numbers x and y, and their least common multiplier also is within the segment, then we can replace y with that least common multiple, and it would also be a valid example. So basically, we need to find two numbers x and y so that y is divisible by x. And we can do it basically if r is at least 2 times L. And one such example would be L and 2L. And that's basically it for problem A. Yeah, we need to check answers because there is not a single correct answer. Obviously, don't want to write checker for problem A. Height 20 pixels. So problem B. Problem B, we have an array, and we start elements in the first element of that array, and we can, in each step, we can go either left to right, and after doing step, we add the value in the corresponding the value of corresponding element for array that we will stand on. But there are some limits on going left. First, we can't go left 2 times in a row, and second, we can go left at most z times, where z is up to 5. So I started this problem with some weird solution that didn't work out. In the end, I don't want to try to describe it. Instead, we can do a pretty easy dynamic solution. We would have an array z times n, z times k plus 1, doesn't matter. And we basically, on each step, we first, like, for each element, we can get there from the left, or we can get there from the right and with one less used left step. So you could, as you can't go to the left 2 times in a row, you can calculate going from left to right from I minus 1 to I, and going from right to left from I to I minus 1 in the same sweep. Yeah, and that's basically it. You will see the solution when I will stop to do that stuff, this weird thing, really. Because yes, basically, if you do several steps, if you step to the left several times and then go to the right, so if you step to the left not at the last possible moment, you will always want to do that in the same position, because you basically add I a, I minus 1 plus AI each time. But considering the last position, it still got weird, and because z is up to 5, there is really no problem with just doing the dynamic solution. If you can do the simplest, basically, you want to write usually the simplest possible solution that will easily fit in the given constraints. And I kinda violated this rule here. Those punished with Ganser, if I remember correctly. Also wasted quite some time in this problem. So if you have any questions, don't hesitate. Fire them up in the chat. I will gladly answer if I can. Yeah, I made a lot of mistakes in this problem. Probably had not enough sleep this night. Something like that. Mm. That's the moment you understand that basically the solution is very bug prone, and it's very hard to find bugs in it, which is a rather bad situation. Yep, yep. As you can see, I first wrote something similar. You need to uh, like you basically almost always want to go left in the same position, but sometimes you want to like do some your left steps on the same position, and then you go all the way to the right and do just one step left at the end. And yes, I tried similar solution, but after getting an answer and trying to make it work, I decided just to scrap it and write dynamic solution because it's much easier to write correctly. As you can see here, you probably just need to yep, I totally agree. Basically, as I already said, the right principle should be you should write if you have like several ways to solve a problem. You should select one that will fit time limits, but the easiest is the easiest one to write to implement. Yeah, you can see that I will remove basically my whole code in a couple of seconds. I think. The state is basically how much time we have gone left and in which position we are currently. You don't need to make it really memory efficient. You can have that times and memory. It's not a problem with these constraints. Also here I forgot to initialize my array with zeros. It led to funny things that I have correct solution for test one on my computer, but wrong answer test one on the system. Well, because it's undefined behavior and you don't initialize your arrays. No need to have k as a set. If you know how many times you go left, you know at which position you will end up after k steps. Yes. So here you can go right from I minus 1 to I, or you can go left, and then you can go left from I to I minus 1 if you hadn't used all your left steps. Yep. Then we just iterate over how many times we really want to go left. That's basically it. We just need to the initialization of our array at the top. That would be the correct solution after that. Here we have from console test one. Good thing that you actually can see your output on the server on test one during the contest, which is a nice feature of Codeforces. And course, thanks for the follow. And you can see very big number, which is basically, yes, indicator that you have some kind of either underflow or an uninitialized memory. Well, 16 minutes for two problems wasn't a good result for this. So problem number 3. There is a string, and we want to remove some characters from the string to make its left shift equal to its right shift. Well, basically, if left shift is equal to right shift, then either all the characters in the string are the same, or there are or the string have even length, and all characters on even positions are the same, and all characters on odd positions are the same. It's very easy to see if you write down basically what what conditions left shift equals right shift force on the string. So here we have also dynamic solution where state is given to characters. What is the longest subsequence of given prefix we can have using these two characters alternatively. The solution would have complexity 10 times n, as you can see here. We also need to notice that if for like if first index is not equal to the second index, we actually can't always use this sometimes because if it's odd, we need to decrease it by 1 because like we can have this alternating characters only for even length strings. I tried some hacks, didn't really work out, and yes, we need to just like subtract remainder to the model of 2 from where I is not equal to j. You can see we like solved problem C much faster than problem B. And here we go. Okay, problem D. Here we have n copies of segment L1 R1, also n copies of segment L2 R2. And they are indices, so we have like and our score at any given moment is some sum of intersections of segments with the same index. And we also have, we can enlarge each segment by one to either side, either to left or to the right. It will cost us one. And we need to find the minimal cost of making our score k or more. So the thing is, we can say that we have like we have big segment, which is like the minimal segment that contains both L1 R1 and L2 R2. If we if after enlarging both segments at index I to the big segment, if we still have had not enough, our score is still less than k, then we can just do it. Because basically, like we have two options. We can either take some two segments that we haven't touched so far and start to enlarge them so that they intersect, or we can pay two. If we have like aligned at least one such segment, we can pay two to increase our score by one, just by enlarging both equal segments to the left or to the right. It doesn't matter. But the thing is making our segments aligned equal to this big segment is always cost less than 2 times that segment length. It's cost basically difference between 2 times its length and the starting, the initial length of segments. So if we can, even if we align these two segments and we still hadn't achieved score of k or more, we can safely do just that. And if it's not true, then we basically have to check to choose between enlarging some already aligned segments and paying 2 times score we still need to get, or trying to, or first paying some predetermined cost so that this segment became touching, and then paying one per how to say it, one per desirable score. Sorry, should have thought how to spell this out in advance. Anyway, first we check if we already maybe have enough of intersection. If yes, then we don't need to do anything, so the cost is 0. Then we also calculate distance that we need to, basically how many steps, how many we should pay before we will get any score from given pair. Yes. And length is root of the containing segment. So yes, first we check if we will fit. We can fit one more segment alignment before we need to do anything else. If yes, we just do it. Paying cost equal to 2 times len minus sum of lengths of segments. But we shouldn't add like len, we should add len minus base points because we already like accounted some points right away. So yes, I will fix it shortly. So if we haven't aligned any segments, we can't really pay 2 per point. Hence it can't be answered. Yes, here we go for base. Yep. Prices would be answer plus 2 times k minus start, which start is not really good name for a variable, but it's basically our score. Should have named score and not start. Here we first pay dist and then k minus start. And suppose we aligned all the segments, then our only option is to pay 2 per remaining points. So if we hadn't like exited this cycle before, we should just print answer applies 2 times k minus third. Okay, please accept it here. Problem A. So here we have a calendar. Basically, we have a year where there is m months. Each month is d days, and we also have. Oh, I just like try to explain it during the time we solve the problem D. You probably can. I'm not sure. I guess on Twitch you can rewind a bit back, and you can then listen for my ramblings about problem D. But yes, sorry about that. Here, problem E. Once more time, we have a year. It's like m months of d days each, and we also have a week of length w. We say 2 days can be confused if basically they are the same weekday, and also if you will write day and month of the first one, it's xy, and for the second one, suppose it's yx. Then those two days can be confused. So yes, we can write like the correct equation, basically m times, oh sorry, suppose we have like day in eighth month b's day and b's month eighth day, and they should be the same weekday, yes? Yes, we have this equation, so we will transfer some of the terms, and we will convert this to so that yes, I minus b by d minus 1 modulo w is 0. That way, also we know that a and b is not more than minimum of d and m. So we basically divide w by GCD of w and d minus 1, and then we want to find number of pairs AB such that A equals to B mod this transform W, and A and B no more than minimal of D and M. It's very easy question actually. I have some doubts about the order of problems in this contest. Yes. I'll be right back. I hope I will not miss the next problem. Sorry. Yeah, still writing this. So we first like select A and B is equals modulo W, which remainder. There is two types of remainder because like suppose we need to select numbers from 0 to 5, and we have remainder 4, modulo 4. Then remainder 0 and remainder 1 have 2 exemplars, and remainder 2 and remainder 3 have 1 exemplar. And we need to solve for them separately. This is it for problem E. And we are on to the harder problems of this contest. So problem F. In problem F, we have some segments of two possible colors. We need to select some subset of these segments such that no two segments of different colors have common points. No, I'm actually type with two hands, but with basically two fingers only. I'm not sure why do you think I am typing with one hand? Anyway, back to problem F. So what we need to do is basically as usual. First, we need to compress coordinates so that they're up to 2 times n. Then we need to sort segments by the left end. And also we need to notice that if we know the last like if we go from left to right and we know the rightmost segment that is in our set, then we can that's enough information for us to determine if we can add a given segment or not. So this is basically n squared solution, easy n squared solution. And what we will do is we will use segment trees with the following operations. We can add a number on a segment, and we can find the maximum on a segment. That way we can determine what is the do you realize that the contest is pre-recorded during the live contest? And me explaining is happening now. Yes, I am talking over screencasts. That's absolutely correct. So, yes, back to the problem. With a given segment, we need to like what is the maximal answer with a given with this segment. First, we need to find like we will have two segment trees for color 1 and for color 2, and basically we will store the segment 3 will contain the maximal answer if the last segment used is have right end in this point and is of this color. So when we look at the new segment, first we need to look to the tree of the other segment to the left of it, to the left of the left end. Then we need to look to the tree of the same color to the left of its right end, update value in this right end, but also there could have been some segment before that the same color, which left end is to the left and right end is to the right. We can solve this by adding 1 to all positions to the right of the right end of the right end of this current segment. Sorry, there is some weird artifacts on the screen. Okay, I think this got fixed eventually. Yes, and that's basically what we do. First, I tried some kind of weird solution without segment trees, but I don't think it's possible to solve it that way. Because basically I tried to add, and sometimes I would add something to the answer that I shouldn't add to. Sorry for one more time there's things that I'm saying, but anyway, that's not that hard problem, but I kind of spend a lot of time on it because I once again tried to do something fancy instead of going for segment trees right away. So yeah, there would be a lot of typing and trying to kind of feed the answer. So it's a good time for ask any questions that you have. Before we go to the last problem. Here you can see me thinking in my head. I'm not always use a whiteboard. Anyway, I guess we can speed it up a bit. There would be somewhere to erase for some time, but they would be deleted in the end, so don't pay any attention to them. What's up? Seems video hanged for some time for some reason. Let's keep it up a bit. I'm not sure what's happening. Sorry about this. Well, yes, with segments, it's usually a good idea to see if you actually want to like it's usually a good idea to see if order by either left or right hand. Ordering the segments by left or right hand will help you solve the problem. I haven't obviously seen this exact problem before, but I have seen something similar. Let me see if reopening this will help. It doesn't open. That's bad. Let me try to fix it. Sorry. Sorry for these technical difficulties. Anyway, yes, like these problems with segments are quite popular. So there is some known tricks how to do them. Okay, I think I fixed all the problems with the video. Uh, I guess there should be tutorials somewhere on the internet or even on Codeforces likely, talking about problems with segments. But I don't have a link. I've sped the video up a bit so that we won't spend a lot of time just looking at me writing some weird incorrect solution before I try to before I will fix it. Segment tree is one thing, but like problem with segments is quite another thing. I mean, yes, this is both a problem with segments and a problem with segment tree, but I was answering more generally about the about problems with segments. For segment tree, yes, there is tutorial on Codeforces. I quite recommend it. But here we have quite easy segment, quite simple segment tree. We just need to add on a segment and return maximum on a segment. It's very like easy operation, very simple operations. What is hard in this problem is making coming up with the initial with the solution itself. How to use that segment trace, because we use segment trees basically to speed up dynamic solution that would naively work in n squared time. We finished with our incorrect solution. Try to do some debugging. And I think it was the moment I realized that it just like no way to solve this problem. Without segment tree-like structure. It's just once again, I still made a mistake. I tried to use fennec tree. Fennec tree is also not enough. Here, probably there is a way to make fennec tree work. But you need fennec tree with update on a segment and query at a point, and you need to rewrite usual fennec tree to make it work, because usually fennec tree allow update at a point and query on a segment. Okay, so there were some questions. Do I stream regularly? I started streaming regularly like 3 weeks ago. I will try to do at least one stream per week, though I'm not sure if I would be able, like if I would have time. We'll see. But this week I would even do 2 streams. Another one tomorrow. And the second question was about solution with maximal matching. What's your solution? But even if we have like solution, if we have some solution with maximal matching, we probably will have at least 200,000 edges. And while it can pass, I don't see why it should pass. It's much slower solution. I guess. Well, if we can find matching greedy, this is usually some kind of dynamics. So why we should call it matching? I mean, probably. I don't know why it's held it up again. My. Sorry, there is some technical difficulties today. Let me try to fix it again, because we are currently like trying to write the correct solution finally. Sorry. So basically, when we do some kind of, if we do some maximum matching, this way, yes, it's probably solvable this way as well. Yes, I guess. Yes, it's true. It's very good observation that size of independent set plus size of maximal matching, maximal independent set plus size of maximal matching is number of basically number of vertices. Yes, but I came up with some other solution, which is likely equivalent. So here we have our desired segment tree. Yes, we remove basically everything. And we hung it up again. What's the actual hack? Sorry. Okay, let's skip a little bit. I guess there is some like bad segment of the video or something like that that gets hangs up on me. So here we calculate best answer if we use given segment, and our right mid position would be it at its right end. And if it's better than current, we update segment 3 with it. Sorry about that. Forgot to turn off notifications. Anyway, we also update we add one to the right of current right, and yes, here we just output maximum in both trees. So once more, what we keep in trees, basically in each tree we keep answer. Sorry, we in S3 in J's position we keep answer if the last segment have rightmost and J and is of color I. And the video hang it up again. Okay, let's just try to go directly to the next problem. I hope it is the last problem with this video. And yeah, I've got there. Okay, so problem G. In problem, oh, sorry, it's already quite into coding problem G. Let's move back. So yes, problem G. We have a graph, and we have some special vertices in this graph. We say, suppose we have directed some of the edges in the graph. We say that vertex is field. I'm not sure what it would be in English. If you can reach it from each special vertex. So for each edge we have a cost. We can pay this cost and keep this edge undirected, or we can direct this edge. And for each vertex we also have a benefit. If this vertex is filled, we receive its benefit. And we need to calculate for each vertex what is the maximal amount of score we can achieve, with score being total benefit we receive minus total cost of edges we haven't directed. if we have to make this particular vertex field. So first of all, let's notice that if we have if we look at the components of double connectivity, so if we will remove all bridges from this graph, for each component we can direct all the edges in this component such that it will be double connected. So we never want to keep them undirected, because we can, at the cost of 0, make each vertex within this component reachable from each other vertex. This way we can actually convert this problem from problem on a from problem on the general graph to problem on a tree by building this condensed tree with like vertices is double connected components from the original tree, and edges is the bridges from the original tree. After we have a tree, as you can see, I would use bridge algorithms from Emacs, which is a very nice resource with many algorithms explained and with implementations. It is in Russian, but I heard there is some kind of project to translate it into English. I'm not sure about if it was successful, if it's completed or not. But anyway, after we have a tree, the solution would be like this. Suppose we have a tree, and we root it in the vertex that we want to be certainly filled. So if we just direct all the edges up after we rooted it in this vertex, we can just this vertex would be certainly the root will be certainly filled at the cost of 0. So cost is always positive. Sorry, total score is always positive. But we can also like if we do some kind of dynamic on a tree where we store profit of a given vertex, which is benefit from this vertex. We always will receive benefit from this vertex. Plus, for each the direct child of this vertex, we calculate basically its profit minus cost of the edge, because if we want to go down from here, we need to have edges both up and down. Yes, there is some special case, but I will go to it a bit afterwards. So, yes, after we calculate all these profits, like using dynamics on the tree, yes, and also one more thing, if some subtree contains either no of the special vertices or all of the special vertices, we do not need to pay the cost of on the edge that going to this subtree. Yes. So that's a special case. One more thing we have to see here, there is a mistake. This should be like in the second clause, this should be not t in next, It should be f up next. And that took me some time to realize. Yes. So if we do this kind of dynamic for each root naively, our solution would be n squared. But actually, if we when we calculate profits, profits, if we transfer a root from one vertex to one connected to it by edge, only profits of these two vertices will actually change. So we can do this update by doing two DFSs. First one to calculate profits, second one to basically go down like standard trick with this problems with a tree where we need to root it in each possible vertex. Yes, is to go down and recalculate only these two vertices, like do everything in the given subtree, and then go up and restore the original values of dynamic for these vertices. So here what we are doing is building condensed graph. Let's once again try to speed up it a bit. We already implemented algorithm of finding all the bridges. I'm still not sure if this problem is better with this like if this trick of converting is from the problem of general graph to problem of trees is good for this problem or is bad for the problem. I'm not sure. Well, this dynamic is basically somewhat greedy. I'm not sure if there is any like easier solution here. Really not sure. But what kind of greedy do you have in mind? So our state in our dynamics would be not only profit, but we also like kind of keep how many special vertices are in this subtree to make like changes a bit easier. I also made a couple of mistakes besides bridge algorithm. But we'll talk about them when we will encounter them. Hi, I'm White Knife. Here I do some thinking about the solution on the tree. This is first DFS where we fill out profit and what we will later rename to special, because we want not only to see if there is special vertex, but how many of them there are. Yes. Um, it's mostly basic helper. I changed a bit how I do input and output, because basically for input I don't want to use streams because it's kind of slow. I want to do some kind of more low level interface for my for my input. So I changed it just a little bit, and I now use free opens to redirect input. But otherwise, it's really very close to basic version. Here we have second DFS, where we actually assign answer. Here we actually shouldn't do this, because it would cause us problems when we go down. We need to keep basic original profit, and just when adding it to the profit of the parent, we need to deduct each deduct edge cost if necessary. Well, I think for JHelper, much more credit should go to Alexei, because I just kind of have shown general direction with my Java plugin, but he did a lot of good work, and I plan to transfer some of his ideas to C Helper. Yes, I understand. Yes. So one other mistake here we have here we only check for if special vertex equals to 0, but we also should check if special vertex is equal to basically number of special vertices. That's why I will get from transfer 5, and will spend quite some time thinking what's wrong in this. Yes, here I do call from else clause, but I also do call from outside which remained from my live template. That's why we have Stack Overflow. Here are some problems with recalculation, which I will fix shortly, I guess. Yes. Need to do this everywhere. I need also to do it here, but I haven't done it here yet. Andrei, thank you for the follow. We have Andrei Stankevich here in the chat. Great ICPC coach for ITMO University. I don't even remember how many times world champion as a coach. Yes, we're fixing this one. So, aside from the bug in the bridge finding, which we will also fix shortly, the only problem here is that when we check special equals to 0, we should also check special equals to number of special vertices. Which I would spend, I guess, next 15 minutes trying to find this bug. Here we have a crash because of debug watches. Happens sometimes in C++. Here we have a cycle, but two of the vertices somehow are bridges. That's because here it should be F up instead of T in. And here's my submit, which will result in our answer test 5. So for the next 10 minutes, I basically would just look at code. Let's skip a little bit, because really nothing interesting happens here. Yeah, finally try to get what's up. For example, if you have only one special vertex, obviously if you only have one special vertex, we will always be able to make all the vertices fulfilled without having to not direct any of the edges. Still thinking. And I think I kinda got it finally, yes. So total number of vertices. Total number of special vertices, sorry. Well, we need to edit everywhere. And that's it. This is the correct solution. Very interesting problem. I quite enjoyed last two problems. A lot of tests for this one. So here I am certain the standings in the final results. I will be fourth. Not that bad, considering we spent quite some time at the start with some really weird bugs. So thank you everyone for joining. If you have any questions, this is the last chance to ask them. Otherwise, I will try to find someone who's streaming something related to competitive programming at the moment. Seems like there is no one. Just said. Anyway, thanks for joining in. See you tomorrow at the same time. There is a second division round on Codeforces tomorrow. Until then, thanks for watching. Bye bye.